Hello, algebra students. Mr. Lawrence here, and we're going to get another video on parallel and perpendicular. You did a good job with it on Monday, but let's get a little more practice. Of course, I hope it's still Monday and you're watching this video, and then tomorrow in class on Tuesday, we shall be doing a little more. So, let's see here. We need to find the equations of lines that are parallel and perpendicular to the equation 2x minus 7y equals negative 8, and it passed through the point 14, negative 3. So let's break it up into two sides. This will be our parallel side, right? And then over here we would do a perpendicular side. All right, so the first thing I need is I need the slope of my original equation. What would be the negative of a over b? That would be 2/7, right? So now I need the parallel slope. Well, the slope of the line parallel will be 2/7. Then I need the x-coordinate, and I need the y-coordinate. The x-coordinate is 14. I got that right from the point. The y-coordinate is negative 3. Now I use the equation y equals mx plus b, y equals mx plus b, and I substitute those values in. So y is negative 3. The slope is 2/7. Okay, x-coordinate is 14 over 1 plus b. Now you are allowed to use a calculator, but remember, you don't need to. 7 goes into 14 2 times. 2 times 2 is 4. I end up with negative 3 equals 4 plus b. Getting the b alone, I get negative 7 equals b. My equation, and this is very important, you need to do this up, y equals 2/7 x minus 7. There we go. Okay, perpendicular, we do the same thing, only we have to use a different slope. So for the perpendicular slope, I use the reciprocal, and I change the sign. The x-coordinate is still 14. The y-coordinate is negative 3. So I'll fill everything in. Negative 7 over 2. 14 plus b. Maybe I'll do 14 over 1 there. And I'll get negative 3 will equal, and when I do my math, 2 goes into 14 7 times. 7 times negative 7 is negative 49 plus b. I'll add 49 to both sides, and I'll get 46 equals b. So my equation is y equals negative 7 over 2x plus 46. That line is perpendicular to this line. If I graph them, you'll see it's true. The blue equation is parallel to the black equation. All right. Let's see here. Let's try one more. This time my equation's in slope-intercept form, but it's very much done the same way. It's just the slope's a little easier to find. The parallel side is over here. And so I know the original slope is negative 3/4. So my parallel slope is negative 3/4. The x-coordinate is 24. The y-coordinate is 2. Okay. I go to y equals mx plus b. I'm always using slope-intercept form to do these. And I just plug them in. Y equals mx plus b. I know the y-coordinate is 2. I know the slope is negative 3/4. I know the x-coordinate is 24. And then b. And so let's see here, 4 goes into 24 6 times. Negative 3 times 6 is negative 18. And so I'm going to add 18 to both sides. And we're going to get 20. So now I write the equation. Y equals negative 3/4 x plus 20. Some of you probably wonder, how do I know what to use? Well, I just solved for b. So I have to use that, right? And I had to figure out the slope for the parallel line. So I use that. When I go to do the perpendicular one, I'll use the same measuring stick. I'll say, what did I have to figure out? The first thing I figure out is m perpendicular, which is going to be 4/3. I'm definitely going to use that in my equation. My final equation, the one that has an x and a y variable in it. Okay, let's see here. My x coordinate hasn't changed, it's 24. My y coordinate is 2. And so I will get y equals mx plus b. 2 equals 4/3 times 24 over 1 plus b. And so 2 is going to equal 8 times 4 is 32 plus b, right? Subtract 32, and I will get negative 30 equals b. So now I can write my equation. Remember, I have to use that perpendicular slope now, and of course I have to use my b. So I go to write my equation. It will be y equals the perpendicular slope times x minus b in this case because it's negative. And there you are. That's it. All right, Mr. Lawrence signing off. Have a good night, everybody.